Daniel Ammann from onocoy, who will present as onocoy. They are also sponsors. So yeah, I'm looking very much forward to the presentation. There goes the mic.
Thank you.
Clicker. It works. So, no worries. I'll stand up at some point.
Right. Thanks for having us. I'm Daniel Ammann, representing the onocoy project. We are an example of how a DePIN project does something in the real world. My personal background is I'm from that school that Mark introduced earlier on, ETH Zurich, but not in building tunnels, but in electrical engineering. Graduated in '97 and founded the first company here looking at GPS. So we built hardware, semiconductors, that is very likely in your car, in your drone, in many industrial applications where GPS is being applied. As part of that project, this company was called u-blox, or still is called u-blox. We worked on the first GPS in cell phones way ahead of its time, so 1999, where you already would have a moving point on a map, and we designed those electronics, which then were built into consumer electronics, into industrial applications, and into cars. We IPO'd, we reached $1.6 billion in market cap, and as part of that started looking into high precision GPS. As Mark already mentioned earlier, your GPS is accurate to around 2 meters, but you can make this more accurate by providing a source of correction data that compensates for errors as they happen in the atmosphere. We're going to have later on, sorry, need to go back one. Later on, Benedict, also from ETH, will talk a bit more about what that means and also about applying AI to that, because that's an intrinsic part, also a fraud detection element that we need to work on as part of onocoy. But first on what we do. So as I said, GPS is inaccurate, it can be compensated. You need a highly dense network of reference stations every 20, every 50 kilometers, where data is being collected, and the data represents the delays from the signals as they travel from the satellites down to that receiver, the delay being in the range of meters, depending on ionosphere activity, depending on troposphere, so the humidity in the lower levels of the atmosphere. Now, we did not invent high precision. That technology has been around for a long time, for 20 years plus. It's being used in high precision applications for land surveying, for agriculture, for various use cases where 2 meter accuracy is not good enough, where you need to have a centimeter or even millimeter. I'm going to talk a little bit about use cases later on. But there's an existing industry. That industry operates such stations, centralized. They roll out a network in countries, in continents. They collect the data and they sell it. Clearly, if an industry is doing that, they focus on where most of their customers are. They focus on areas where they can make most revenue. And that's where all the players focus. So if you look at the landscape of where do you have correction services for high precision GPS, it's the US, it's Europe, it's China, it's Australia, it's Japan. It's also outside of that, but to a lesser extent, there's regional networks, national networks, more or less modernized, but it's a very scattered landscape that you have. Even more critical is the business models that those people do. They come from a high-end, high-value, low-volume attitude, because they've been selling licenses or subscriptions to their services on a per-end device application, which is a hindrance for mass markets. And this is where DePIN comes in, or specifically onocoy for the GPS case. Like almost every DePIN project, you have a supply side and you have a demand side. Supply side being the decentralized part, the part where people can install, everybody here in the room, if you have a rooftop, you can install an antenna on that roof, connect it to our cloud. That device is going to collect the satellite information, and we're going to qualify it, we're going to measure it, and then we sell it on the demand side in a traditional industry in typically pay-per-use models. So decentralized supply, rather traditional Web2 B2B style demand. Our job is to set up the rules of the game. So what do we measure? what qualities in the signal do we look at? How do we incentivize based on what we see? How do we make sure that the network is rolled out in the interest of the generalized demand side? So not oil stations at one spot, but mostly equally spread around landmass of the planet. And then also to quality assure that towards the end clients, because those people, they're used to buy from a company which guarantees them availability of the data, quality of the data in SLAs. But as a blockchain project, we cannot directly do that, but we can give SLAs and guarantees through indirect means. Talking a little bit about the supply side, here's a few examples. On the left-hand side, you see a professional install. Not sure if there's no laser. The left-hand side, this is a professional install of a correction service provider, and they deploy those stations every 100 kilometers. The station is pretty expensive. It's somewhere between 10 and 20,000 euros as a capex, and it's somewhere between 2 to 4,000 euros per year for OPEX. So for service technicians, for renting the space, for electricity, for redundant communications channels, and that's how traditionally it has been done. On the right-hand side, those 5 pictures, these are real installations of people in our system, in onocoy, that provide the data to us. From relatively sturdy installations, here I think both these examples are from Vietnam. Actually, I'm not sure where this one is from. This is a rather scary network, a scary setup. Scary because when we do millimeter precision GPS, any motion on the antenna will translate into a position error on the device, on the robot, on the drone that is using that data. So our job is to identify such stations that swing in the wind. So that means we also need to have a millimeter per second real-time speed detection of every antenna in our system. And then on the top right, that's a station by Alex, who is in the room right there. He deploys boxes with solar panels in the field. Now, again, our job is to make sure that this box does not move, because if that box moves, then it's going to be super critical to the end application. But just to illustrate, with such pieces of hardware, somewhere in the 500 to 700 euro range, we reach almost similar performance as a high-performance system on the left, with drawbacks. It's not controlled. It may go down. It may move. But because it's much more cost-effective, we can indirectly deploy many more. So we compensate those drawbacks with a much higher population, with much more redundancy. Now on the crypto side, how does the economy work in our system? So we have, in essence, we as the project, we pay people operating those stations with our value appreciating Ono token, and they give us the data that they collect from the satellites using that box. These people, they will trade the token on an exchange, and they got dollar or stable or ETH in return. On the other hand, we are selling the data to an existing industry, the traditional industry. They don't necessarily want to have to deal with crypto and wallets and all those complexities, because either they are not used to do that, or they don't believe in it, or it's just a hassle. And they want to pay in dollars, so we have a data credit that they need to buy from us. So they come with dollars to us, and they get a data credit, a second token, a token that we burn as a function of usage. So once these people consume the data, if they consume 1 second of data, we're going to deduct a fraction of a data credit as a function of as they go. So we can implement a very efficient pay-per-use business model, which we couldn't do in a traditional way if we would have to count usage and send invoices or have credit card transactions. What we then do is, with the data credits, respectively the dollars that we receive, we go to the exchange, we buy back the Ono tokens, and through that we generate value appreciation in the token. And because we are organizationally a non-profit, we need to do that. We need to go to an exchange, we need to take the fiat and buy it back, and and burn the tokens. So we have a deflationary element in the system which allows us to push the value that we do in the real world, the fiat revenues that we generate, into token value appreciation. And that's in a nutshell how the core economy works. Now, what is that data being used for? Traditionally, high precision was used in land surveying, in heavy machinery, construction vehicles, agriculture, auto steering tractors, and many such applications. And it's a pretty big market. It's 250 billion euros worldwide today. And this market is served through a relatively long value chain and dealerships and all sorts of vertical orientations of the different players. And in that, we can play the role of providing the underlying infrastructure for everybody. Rather than having centralized players operate their own, we build one infrastructure that anyone can build on top. So we're not directly selling into autonomous cars. There is companies which do sell into them already, but their problem is the CapEx and the OpEx they have to maintain, to operate, install, and maintain the network. And we can solve that very efficiently in a DePIN mode. On the other side, on the non-high precision positioning side, there is an element of Earth observation. As I mentioned, we can measure the delays in the atmosphere, so we indirectly get a view of what's happening in the atmospheric layers, in the ionosphere and the troposphere, and this in turn can be used to create additional data products that are useful for meteorology, as an example. Or that real-time speed detection that I mentioned earlier, to detect if this pole on that fence is swinging. Since we do that routinely, we can also have a large, highly scalable, decentralized earthquake detector. We detect millimeter per second speeds in real time, and through that we have a perfect view of what's happening on the ground with the plate tectonics and with earthquakes. Just very quickly, we position ourselves horizontally, meaning unlike many DePIN projects that go after an existing market and compete with an existing Web2 industry, we don't do that. We solve the CapEx, OpEx problem for an existing industry and dock onto an existing industry that has been around for 20 years and that knows how to serve in certain verticals. So all we do is provide that ground reference network that anyone can build on top. And that works beautifully. We have, as of today, we have 3 major correction service providers from the industry who use our data to densify their networks, to expand their networks, and ultimately to bring the cost down of their operations. Where do we stand today? We currently have almost 5,000 stations running 24/7. They provide us every second, they provide us measurements from that point where the antenna is. The product as such is available since more than a year. We have first customers on it. Year-to-date revenues is $100,000. And you see here a few screenshots of the platform. For example, in the center, this is Germany, fairly dense network in Germany. On a global scale, we have pretty good coverage throughout Europe, throughout the US, Latin America, South Africa, in regions also where traditional networks wouldn't necessarily go because it would be too expensive. Their back of the envelope business plans don't justify them investing into the infrastructure, whilst in a community model, it is doable. Second to last slide, the community, this is all based on community. So the people that operate those nodes, that help each other, that in parts even build their own hardware, so they can buy a piece of equipment, they can put it on a Raspberry Pi, put a Docker image on it, connect it to us, install the antenna, or they can buy a complete box that just works. So somewhere between $200 and $1,500 and you're in. Community also helps each other in optimizing the setup, into supporting, into explaining, because there's some complexities around how do we measure the rewards and how do we incentivize based on what people do and how they configure the devices. We had our TGE in July, and we are on Solana. And we used to have a points system before, and with a very creative method, we convert those points into the value appreciating token. This was not a hyped up token launch and not meant to be exit liquidity for VCs. It was rather an organic token launch for the miners in our community to understand what is the value for what they're doing. Hence, there's not much trading volume, there's not much liquidity, but this is okay for the time being. We know the ecosystem starts to accelerate now that people recognize the value, and actually we see we have double the growth rates on the number of stations that join us, thanks to the DGE, and the value appreciation will come as we create revenue. Finally, financing. About half of the project is financed with non-dilutive grants, government grants, European Union prize money, and more recently also from ESA, so the European NASA version, their funding work, and that also Benedikt is going to mention later on, their funding work to study fraud detection in such a mode as we operated. And with that, I come to the end, unless there is any questions, which I don't think we have too much time, but Sebastian, go ahead.
A very quick one. You said you buy back tokens. How often do you do that, since you stated that there's limited trading happening?
At the moment, we do it when we feel like it.
Okay.
Since the project is not, it's not yet on a break-even level. So we also, from a cash flow perspective, we need to look into that. We obviously take note, and we will push the revenues into the token as we move ahead.
Okay, thanks.
Thank you. Just a quick question. So let's assume I'm a farmer in Southeast Asia, and so I want precision device. Why should I use your solution? Why can I not build just for my field, like a precision device to do that? Is that possible?
You can, and many people actually do that. If you just have your farm, you need one station. You can buy such a station for yourself. Yeah. And it serves all your robots and your tractors and everything. Okay. At the same time, you can also provide the data that you collect to us. Other people. Okay. And then your neighbor can also make use of it. All right. So we are also providing additional monetization to people who already have an installed station or who want to operate their own station and provide the data. So it's a sharing of data.
Yeah. Let's one more round of applause for the speaker. Thank you.